Okay, this video is just to introduce what an imaginary number is. It sounds fake, but there's a classification of numbers that are called imaginary numbers. And for any of you future programmers, imaginary numbers are used in vectors, and anytime in a game that something rotates or turns, moves, vectors are involved, which deal with imaginary numbers. How you get an imaginary number is when you take a square root of a negative number. So remember, normally when we're taking square roots, we're taking square roots of positive numbers, and the result could be either positive or negative. But there are no real numbers. You can't multiply -5 times -5, and that would equal -25, because a negative times a negative is a positive. So when we take the square root of a negative number, we're at kind of a dead end, except for now we have imaginary numbers. So introducing the square root of -1, we call I. And the I is kind of this italic, kind of this curved letter that looks like that. You do not want to write it like that. It ends up just looking like a 1. So you kind of curve it a little bit. And so I'm going to show you the 4 critical powers of I that you will use from Algebra 2 and moving forward in math. You'll be using these. So the square root of -1 is I, or I to the first power. So I to the first power is just I. Well, when you multiply square root of -1 times square root of -1, well, remember, when we're simplifying irrational numbers, what's the square root of 2 times the square root of 2? Well, the root times root, the root goes away, leaving 2. Another way to think about that is the square root of 4. The square root of 4 is 2. But nonetheless, whenever you multiply a radical times itself, the radicand symbol goes away. So, square root of 1 times the square root of 1, or square root of -1 times the square root of -1, well, that's the same as I squared, and that equals -1. So square root of -1 times the square root of -1 is -1, but this is I, and this is I, so I times I is I squared. So I to the first is I squared is -1. Well, now you're going to have square root of -1 multiplied by itself 3 times. Well, we already know what 2 of these multiplied by become -1. Well, -1, well, what is, and we know what the square root of -1 is. The square root of -1 is I. So now we have I times -1, which is -I. So I cubed. So when you multiply -1 multiplied by itself 3 times, the result is -I. And then now look, when we do that 4 times, -I, square root of -I, 4 successive times, you get I to the 4th. Well, think about laws of exponent. When you have x squared times x squared, add those exponent, you get x to the 4th. So I squared times I squared is I to the 4th. Well, look at what I squared is. -1 times -1 is +1. So those are the 4 progressions. And the reason that comes in handy, especially for those of you that are going to be taking the ACT or SAT or PSAT sometime in your near future, or just on a Algebra 2 or pre-calculus final. Here is the example. So they might ask you, what does I to the 25th power simplify to? Well, using law of exponents, you want to get multiples of 4 because I to the 4th is 1. So what is the closest number to 25 that's a multiple of 4? Well, that's I to the 24th. Well, I to the 24th, since that's a multiple of this, cancels to 1. And then I to the 24th times I to the 1st. Well, I to the 1st is just I. So I times 1 is I. So I to the 25th simplifies to I. All right. Now what about I to the 99th? Well, the closest number is I to the 100th, but we've gone too far. So I to the 96th would be a multiple of this. So I'm going to rewrite I to the 99th as I to the 96th times I to the 3rd. Well, I to the 96th, since it's a multiple of this, that just becomes positive 1. And what is I cubed? I cubed is negative I. Negative I. So 1 times negative I is negative I. All right. So that's how you use I to the 1st, I squared, I cubed, I to the 4th to simplify numbers. But if you are working with vectors and you are going to graph this stuff, here is the example. It looks like it's a regular coordinate plane. Let me get these all out of the way. But instead of the y-axis being y, we're going to call that the imaginary axis. So let's look at our first example. So these examples are all in, the complex numbers are in the form of a plus bi. Think about a going along on the x value and b as a y value. Imagine that a plus bi looked like x comma y. So we have -2 on the x-axis, and we go down -3 on the y-axis. So we come over -2 and go down 1, 2, 3, and that point right there is -2 subtract 3i. And if you wanted to say that that's a vector, that's the notation for vector, and then you draw the arrow. There's your vector, and you use the imaginary plane. But let's just plot the complex points, no more vectors. What if you just have I? Well, think about that as 0 plus, so 0 on the x-axis and up 1. So that point right there would just be I, or 0 plus I. What if you just had 4? Well, that is saying 4 plus 0i. So 1, 2, 3, 4. So that point right there is just 4 plus 0i. And it really is a good idea. I guess you're going to plot that point to put 0 plus I. I should not set some bad habits. All right. And then 3 plus 5i. So 1, 2, 3, up 5. That point right there is 3 plus 5i. Then we have, back to red, we go over 2, down 2. That right there is 2 subtract 2i. And then finally, you have -1. So go over -1 and then up 4. That point right there is -1 plus 4i. So that's how you plot points, plot complex numbers. And then the first part of the video is how you simplify values of I. All right, that's it.